Hello fellows and everyone who is still wondering about the high availability and disaster recovery of their SQL Server. Because today we're gonna be talking about the SQL Server always on availability groups feature. And guys, what I wanted to mention is that in fact here we are at the next step about the high availability and disaster recovery of SQL databases by leveraging SQL Server AlwaysOn technology. In the previous episode, we covered the deployment of the well-known SQL Server failover cluster instances, and we did that on Windows Server platform. So today we continue working on our setup, deploying a DR site, thus making your production resistant to any kind of accidents and failures. But just we get this broadcasting started, let me make sure that you guys can see my screen and hear me well. So in order to do that, please drop me a quick message into the GoToMeeting chat box, and this way we figure these things out. So let me then quickly introduce myself and we get this webinar started. My name is Bogdan and I'm Solutions Architect here in Starwind. And you know, guys, despite that it's summer, the great time of vacations and entertainments, we are working hard to deliver virtualization and storage solutions to ensure your business continuity. And if you ask me, I would highly recommend addressing your attention to the Starwind vSAN, especially for vSphere environments. Because the thing is that we have redefined the concept and the licensing model, as well as added some new features, so that's worth checking. Alright, but let's get back on our today's topic. So as it was previously announced, today we are going to discuss how to build up a DR site for SQL Server FCI setup by utilizing SQL Server AlwaysOn availability groups feature. And for those of you guys who have missed the first part, I could quickly go through the setup we have eventually managed to deploy within our test lab. So what we have done, we've configured SQL failover cluster with just 2 nodes. We use the direct connections in between the nodes, and each of that servers, each of the cluster participant was loaded with the local storage, and we eventually utilized Starwind vSAN for creating a shared storage in between the nodes. This setup was essentially providing redundancy at multiple levels, and therefore protection for the SQL services accessing the instance, which can be failed over on an available node of the cluster. As for the data, all the data was stored on Starwind Virtual SAN itself, which, again, as I've already mentioned, included mechanisms and features to protect data from any kind of failures and accidents. But what if something happens to your primary site? What if it is a natural or, let's say, man-made disaster? Let's imagine it is kind of a hurricane or a total blackout that may happen at your primary site, at your primary data center. Or let's say, what if you want to make your data available for other purposes like backups? That is, as you all may know, can affect the performance of the entire system. And if you want to do that without necessarily affecting the performance and stability of your production SQL cluster, so then I would definitely recommend addressing your attention to the SQL AlwaysOn availability groups feature that would allow you to address these scenarios. So guys, during this webinar, you'll be able to find out how to properly integrate FCI with AlwaysOn availability groups, which offers the high availability and disaster recovery, which in its turn all rolled into one cluster. So this scenario is also perfect for guaranteeing no data loss when failing over to a new node of the SQL FCI. Just please keep in mind. By the way, let me drop you the link to the previous episode of this webinar, because there is someone else who will be interested in refreshing his memory. So Just a second, please. Here we go. You guys, please also know that this webinar is being recorded and the corresponding video recording should be uploaded to our website and also to our YouTube channel, I guess sometime next week. Please also remember to rate this webinar at the end of broadcasting. Alright, fellows, it seems that we are good to move on. So now you can see on your screens a quick overview of today's topics. So for starters, we'll quickly go through the SQL Server AlwaysOn technology and try to figure out its scope and main things about it. We would also try comparing FCI and availability groups in terms of features and available functionality. Then I would still love to address your attention to the key points and benefits of AlwaysOn availability groups. Finally, I'll show you how to combine FCI and availability groups within your production environment, deploying a true HANDR setup of SQL Server. So it's gonna be a cherry on top, you know. And after it's covered, we'll jump into our test lab and see how the system is configured and how all these things work in details. So I believe you all remember that SQL AlwaysOn was firstly introduced in SQL Server 2012, and its main purpose was kind of delivering a set of high availability and disaster recovery features, which included failover cluster instances and availability groups technologies. And you know, it has been also described as the next step of database mirroring and should has been enhanced the existing technologies of database mirroring and failover clustering to provide a strong layer of high availability and disaster recovery. And you know, no wonder Microsoft needs to improve database mirroring since it has, you know, several important limitations and been outdated. So first, database mirroring is limited to a single failover partner, and there is no chance to add an additional failover partner. So in addition to that, I would say database mirroring is capable of failing over only a single database at a time. And another thing that is worth mentioning is that you have to choose either synchronous or asynchronous mode. I mean, one way or the other at a time, as the database mirroring doesn't support combination of the replication modes. Finally, the databases on the mirroring server are instead of recovery, so they can be simply accessed. I mean, they can be directly accessed if you want to. And in order to use the data, you must take point-in-time snapshots of your databases. So that's the only way. I would say that's the way the things were going that time, my friends, and therefore Microsoft has been forced to reveal to the world much improved model of their flagman HANDR technology, which boasted a wide range of the enhancements and also consisted of two separate technologies, failover cluster instances and availability groups. And talking about the main difference between them, I would highlight the fact that FCI does instance level protection, while the availability groups can do a database level protection only. By the way, availability groups technology doesn't require a shared storage, while in case of the failover cluster instances, it is considered as a strong requirement. However, both technologies rely on Windows Server failover clustering, as the foundation for its implementation, and you know, it's not that unusual out here. I would say it can be even considered as a signature trait of Microsoft. Well, for what it's worth, it's all been covered just on the surface, as you can see. That's why if you guys want to learn more about the technology itself, please make sure to watch our previous episode that is already available on our website and also on our YouTube channel. And we are moving on. Now I'd like to quickly remember all of the main differences between AlwaysOn FCI and AlwaysOn availability groups one more time. So please take a look at this table where you can see all the differences classified by the key categories. So first of all, when it comes to required storage type, as I've mentioned before, AlwaysOn FCI requires a shared storage, while AlwaysOn availability groups doesn't require a shared storage in any form. As for the HA level itself, again, as we already discussed, AlwaysOn FCI can do instance level replication, and as for the AlwaysOn availability groups, they can do database level only. As for the data protection, according to its architecture, FCI unfortunately doesn't provide any data redundancy mechanisms, while in case of AlwaysOn availability groups, each of secondary availability group databases are redundant copy of the primary one. And again, it's all due to its architecture. Database availability. So again, as you may know, SQL Server FCI is operating in active passive mode, and there is no concept of a secondary replica. But when we're talking about AlwaysOn availability group, we can say for sure that DR replica can be active secondary, but it can be read-only. I mean, it can be launched in read-only mode. As for the failover resources, AlwaysOn FCI enables you to failover server, instance, and database, all things together. And when it comes to AG, it can fail database only. As for the client's connections, when you use AlwaysOn FCI, all of your clients or applications connect via virtual server name, while in case of AlwaysOn availability groups, all of your clients would be able to connect via availability group listener name only. And the last thing I would like to highlight over here is the recovery models. So in case of FCI, there is no special requirements as to database recovery models. And if when it comes to configuring availability groups within your environment, you should keep in mind that database must be all in full recovery model, right? And we go next. So, alright, fellows, let me guess, let me think. So, we are going to start from the top. So, thanks to the synchronous data flow, availability groups can guarantee zero data loss protection. Synchronous mode basically ensures that once a given secondary database is synchronized with the primary database, committed transactions are fully protected in this case, right? Failover of multiple databases means that all the databases in an availability group all fails over together. It differs from the database mirroring technology where the databases fail over individually, and it also is unlike the failover clustering where the entire instance fails over. Also, AlwaysOn availability groups feature both automatic and manual failover. Note that you must use synchronous data flow in case of automatic failover, and in case you want to make use of the manual failover, you are required to utilize asynchronous mode. And as I mentioned before, availability groups feature doesn't require shared storage at all, so you're able to utilize even kind of a directed touch storage within your infrastructure. And one of the cool features of AlwaysOn is automatic page repair, which means that in case SQL Server encounters certain types of corruption or any other errors, it will simply look to the available replicas to see if they have a clean copy of the page. And if they do, it will repair the page and make a database admin happy. Yep. So the last but not the least, AlwaysOn availability groups can really deliver a performance increase. And it's all due to the availability groups architecture, which means that you can offload some of the read-only and maintenance tasks to the secondary replicas and loading the primary side. Because that's obvious that a lot of these operations can consume a lot of compute and also storage resources, offloading them will optimize the performance on the entire system. So to draw the line, I'd like to say that there is still a significant drawback apart from all the advantages we've already discussed, and this is the cost of the solution. I mean, if you want to enjoy all that features, you need to have the enterprise lights of SQL Server. Yeah, there is kind of a license for SMB and Robust, which can offer some basic functionality and which has been initially included in SQL Server 2016 Standard Edition. However, the feature itself obviously introduces some limitations, like just one database per availability group, just the two availability group replicas, I mean one primary and one secondary. And in my own opinion, the worst thing was the fact that you cannot run backups on the secondary replica. So for those who still considers availability groups as an obvious overkill for their infrastructures, we recommend referring to VM backup and replication, or when it comes to enterprise workloads, you can always utilize Starwin as synchronous replication for building up a disaster recovery site. Despite all of that, let's see how a two-way chain DR setup of SQL Server is brewed here in Starwind. So guys, we took all the best from the Windows Server failover clustering, SQL Server AlwaysOn, and Starwind to give you a robust, flexible, and failure-proof solution. So let me quickly introduce its architecture diagram. So, as you guys remember from the previous episode, we have been configuring a two-node SQL failover cluster. We've been utilizing the direct connections in between the nodes and Starwind vSAN as a shared storage provider. What we have got eventually was a true HA environment with multi-level redundancy, which was able to protect you from the disk failure, two disks failures, RAID controller failure, losing a whole node, and even a whole node and a couple of disks at a time on the remaining cluster participant. But how about a total disaster that may happen at your primary site? Exactly for this purpose, I've added a third node to the cluster and let it run as my DR site. I've also installed SQL as a standalone server over there and configured availability group. As for the installation procedure, it is quite simple and straightforward. I mean, if you wanna learn more about this procedure, if you learn some details as to the procedure itself, please visit our website where you could easily find our guide, our technical paper that describes all of the steps you need to perform in order to configure such a solution. But if we, in a nutshell, you would simply need to install a cluster, yeah? You then install a standalone SQL server. You also use the domain account for the SQL server's account. You disable the Windows firewall. You then create a sample database, set recovery module to full. It is one of the most important things. And finally, backup the sample database. Once it's done, you enable the AlwaysOn feature on both instances using SQL Server Configuration Manager and create an availability group using the availability group wizard. But again, if you want to learn more about the installation process, please refer to our technical paper, which can be found on our website. Right, so we are moving on. And now it's time to jump into our test lab, where I've prepared a cluster that is under consideration, and I'm going to show you all the configuration details. I mean, we are gonna review the system configuration. We then also be able to see how all these things works in details. And finally, I'm going to show you some kind of power outage of the primary site. So we would be able to make sure that all the data is still available on the remaining node, right? So if you give me just a couple of seconds, then I will be able to RTP to one of our node and show you how the cluster was configured. So I'm trying to connect to the first node. Let me remember my password. Perfect. So we are on the first node. And let's imagine that we are now at our primary data center. Yep. So as for the DR data center, it can be located either at another floor, the other floor, or at the other building, or even in the cloud. So I'm running Server Manager at the moment and choosing Failover Cluster Manager. So here it is, our cluster. Under the roles tab, you can see two roles already deployed. The first one is SQL Server Failover Cluster instance, and the second one is our availability group feature that is, again, that was already installed and configured by myself. When we navigate to Nodes tab, we'll then be able to see that all of our cluster participants are now up and running. So everything goes fine. We then go to the Storage tab, navigate to Disks, and you can see that we have only one drive that has been presented to the SQL Server. Again, as I've already mentioned, Starwind here is responsible for making a shared storage. Just a couple of words about how it does that. So it simply takes the local drives of your nodes and then replicates the data on them in between the nodes. This way you get NHA storage. And there are a couple of ways to present the storage to the SQL Server. The first one is that you simply present it as the cluster shared volume, and this way you can expect a little performance increase thanks to the Windows caching. But as for me, I prefer another approach. I've simply presented it as the raw device to the SQL, but that's also can be applicable to this kind of configuration. So actually, it's up to you, and I believe it makes sense, to benchmark, both methods and figure out which one is better, in terms of performance. Right. So what I wanted to propose is now I believe a good time to simulate a total blackout to our primary side. So let me then, but just before we do that, let's make one thing. I'm going to get access to Microsoft SQL Server Management pane. So in order to thoroughly test the functionality of the presented solution, I would definitely need to create kind of a test database and test table, for instance, just in order to make sure that we don't lose any data once something happened to one of our nodes that is located at the primary side. So as for the test database, it has been already created over here. It is called Starwind test. And let's then find a tables folder. Alright, so I'm going to create a new one. Let's name it like test demo. So let's imagine that this is our data we put inside, and then let me then save it. Sounds like that, it doesn't matter at all. I hit OK. Then I refresh all the tables. You can see that the corresponding table has been appeared on the tables tab, right? Okay, guys, so now I'm going to power off the first two nodes, simulating a total blackout at the primary side. So again, just give me a couple of seconds. I mean, it will be quite enough to accomplish that. Alright, fellows, job is done. So let me then now repeat to the remaining node, to the last one, to the third one. the one that holds availability group replica. So first of all, I propose to make sure that the first two nodes have been really powered off. In order to make sure that I'll need to launch Server Manager and then Failover Cluster Manager. So now we're trying to connect to the cluster that is actually should have been powered off. I mean, now it should be in the down state. So yeah, as you can see now it is unavailable, and if we click on it, we'll then should see you know, that the first two nodes really have been stopped. Yeah. Alright, so the last step would be checking that data if we put in the our demo table is is still there. In order to do that, I would need SQL Server Management pane once again. Let me find it. Here it is. Alright. So I'm navigating to the same folder, to the tables folder, and as you can see, the data and as well as the demo table has been replicated to the third node. And now when I click design on it, I should see the data itself. Here it is. So we made sure that this solution works, everything goes fine, and yeah, that's the way these things are going, my friends. Now I believe it's a good time to conduct a Q&A session. So if you have any questions, I'll be more than happy to answer all of them. I'll give you a couple of minutes to come up with the questions, and then we'll get this thing started. Alright, fellows, I've got the first question. Diana is asking, can I leverage your hybrid cloud model in order to keep the third node completely offsite? Yeah, that's possible. Even more, you would be able to deploy the entire cluster completely in the cloud. Because Starwin vSAN supports both scenarios. The hybrid cloud model, when one of your nodes is located in the cloud, and the completely cloud-based scenario where the entire cluster can be deployed in Azure or AWS. Thanks for the question. Okay, I have also received the next question. Peter is asking, you mentioned the new Linux version of your virtual SAN for vSphere environments. How about the licensing model? What has been changed? So you now have a great chance to get the 3 licenses bundle for the price of 2 licenses. So it has been a main change in the licensing model. Yep. So this is the answer. In addition, I would say that you are now not limited by the storage capacity, by some of the features. So it is licensed per node basis, So 1 license allows you to run a single node. 2 licenses allows you to configure a cluster. Alright, fellows, if there are no more questions, I want to say thank you for your attention, thank you for your time. Do not forget to rate our webinar at the end, and stay tuned. See you at the next webinar. Bye.